Hi, in this video we'll be going over the C# video tutorials. We'll be doing we'll be talking about methods. So methods can be used to break a complex program into small manageable pieces. This approach is known as divide and conquer. That might be a Microsoft term. In general terms, I've never heard that one before. But anyways, in general terms, breaking down a program to smaller units of code, such as methods, is known as modularization. So we've done this before. We've talked about it in Java, probably maybe somewhere else. But hopefully you guys understand. So we'll actually write these out in a sec. The two types of methods are a void method. So a void method simply executes a group of statements and then terminates. And the second type of method is a value returning method. So a value returning method returns a value to the statement that called it. So let's just type these out here as well. So we have methods, C#. So C# methods. So that's the title. Some notes, basically just comments, turning them into notes here. So then we have, so methods can be used to break a complex program into small manageable pieces. So this is known as divide and conquer. So in general terms, breaking down a program to smaller units of code, such as using methods, is known as modularization. Modularization, that's probably a term you might get tested on. So that's the definition right there. In general terms, breaking down a program into smaller units of code. So you take a big piece of code, and then, so let's say you take a pizza and then you break it down into pieces, into slices. And those slices can be methods, known as modularization. So you can organize you can break down the code into smaller pieces, basically making it easier to eat the pizza rather than having to pick the whole pizza up and eat it in one go. You can cut it into slices or pieces of pie or whatever. So for the next part then, we have two types of methods are so we have a void method. So you've seen me use void like millions of times. So a void method simply executes a group of statements and then terminates. So there's no return type or value. So the second type is I should have maybe just done this here. Two types of methods are a void method, and we have a value returning method. So this can be, so let's just say this. So a value returning method returns a value returns a value to the statement that called it. So this can be a string, so you can return a string. Return a string, int, double, decimal. So far, like, that's pretty much all we've been returning. Those are the types in C# that we've been using. There's also custom types, like object types we'll probably talk about later on. There's different things you can return. You can return null for no object. We haven't done that yet. We'll probably get into that. But for now, you can return values like this. You can return a string. You can return an int. You can return a double. You can return a decimal. So we'll talk about that. So when you create your method definition, you have to include the return type. So I'll show you guys how to do that. So let's have an example here. So this is using one long sequence of statement to perform a task. Pretty much a sequence of statements to perform a task. So this is just example here. For example, we could have, let's just say we have namespace, whatever, smoothie. Then we could have here something else, so we could have public partial class. Form1 inherits from form. Whoops. Do we have an event handler? So we have an event handler here, so let's say we have private void my button. So we have private void my button underscore click. Takes parameter object sender. It takes parameter, sorry, let me just do this again. So we have the takes parameter object sender, and then event args e. Object should be capital, shouldn't it? Object should be capital. And then event args e. Then we can have statement. Let's just say code. And imagine we're just continuing that code all the way down. Whatever statements you're gonna do. Okay, so basically, instead of this, what we've been doing before is we've been just having everything happening in one. This is pretty much an event handler. It's like a method basically, but instead of just having one large method, we can create other methods instead of just one event handler. So we could have an event handler to like get our button set up, and we could then call the button click or something in here. We could say like want button click to execute. We could have a method under here like we could have I should probably put this down. What happened here? Okay, this happened here. Okay. So instead of that, we can call button click here. We could have like, let's just say button click returns an int, like a 1 for if it succeeded, 0 if it didn't. So here we could have like int button click. Takes parameter like same thing. Let's just say it takes the same parameters. Let's just give it another parameter. Let's just say takes a boolean fired or something, like whether the button was clicked or not. Something, I don't know, just something random. So let's just say we have that, and then here we could have like button, like we'd have code here to actually handle, like not handle, but we could have code that actually maybe executes the button click at startup or something. Then here we want to call that. We could have another method here that says like we could have like void get, because in code you often use getters and setters. You can even generate them somehow with a right click and some button. Sorry, not button. Maybe there's a shortcut to do it, or you could do it up here in the tab. Obviously, I mean, often you just see me code them myself. It's easier just to code them yourself. But let's just say you have a variable up here, like a field. So let's just say here we had a field. Let's just say it was like a string. Let's just say we had a string data, whatever, points to some maybe it's user data that we're getting as input. So here we could have string user data. Here we could say void get user data or something, or just data with no parameters. We could somehow get input maybe from a text file or something. We could create a stream reader here. Then we could do that stuff that we already did, you know, get all the data from the path and all that, read it in with a loop. We could do that here, and then here we could call, in this event handler we could call here, we could say we want to call get user data. Then once we do a method call like this, it would execute this method here. And instead of just writing all these lines underneath, let's say you wanted to call it another time at some other point in the code, maybe down here. So instead of having to, this is the part where it's useful, is that you don't have to write that code out again. You can just call the method. One line here to save you more code, basically saves you from writing the code over and over again. It helps you organize it so you don't have to just have everything set up so it works in one method. You can have everything kind of organized so you can call them when you want, space them out, call it again, space them out, call it 10 more times in a row, or one time up here, one time down here, maybe a few times in the middle. That way you don't have to like write the same lines of code like 100 times in different places. So it saves you time and space. It's a better way to write code. So that's pretty much it. So we'll talk about void methods here. So let's just say down here. Oops. So let's just say here we have void methods. So let's just have void methods here. Some more notes. So a void method simply executes a statement it contains and then terminates. It does not return any value to the statement that called it. To create a method, you write its definitions. A method definition has two parts. A header, so the method header appears at the beginning of a method definition to indicate access mode, return type, and method name. So pretty much a method header, you can call it a definition, a header. Sometimes I call it a definition. Header is probably the best word. But either way, it's the same thing, definition, header. And then the second part of the method definition is the method body is a collection of statements that are performed when the method is executed, so you guys know that. I don't think we really need to type all this out here. So the method header, the book separates a method header into 4 parts. So those are the docs. Okay, so we might need a note here actually, but could have a couple notes here, I guess. Unless everyone just wants to listen to me speak, it's faster, but more time for the code, which might be better actually. So you guys get the idea, we don't really need to do that. Okay, maybe key parts, so we'll just do some key parts here. So we have method definition has 2 parts. So that's a header and a body. Method definition has 2 parts, header and a body. Then we have this part here. So the book, or the docs that I've been working for, they kind of mention, so that's Tony Gaddis, I think. Gaddis or Gaddis, it's part of the Canadian curriculum, Canadian university curriculum, at least at my school. Well, yeah, that's the book that they use. If it's in Pearson, then that's the book that the Canadian curriculum uses. So any Pearson books, if you see a book with a textbook that says Pearson on it, it's probably used in the Canadian curriculum, because all my books are from Pearson. Which is good, because the states, the school that I went to in the States, University of Arizona, they don't have one general place that is like a company of books that they all get the same books from. Like all the schools, like at least most of the schools, or even all of them, they have like, each class has like its own random book. There's no actual company that like has all these books or makes them. But pretty much you. So the method header. So the way that I learned a method header is that it has 4 parts. The access modifier, return type, method name, and parentheses. This is kind of above and beyond, but you may need to know this. You may get tested on some of this stuff at some point. So the method header, a book separates a method header into 4 parts. Access modifier, that's the first part. So keywords that define the access control. Okay, so that's like private. So a private method can be called only by code inside the same class as the method. So some of this stuff we can jot down in a sec. So a public method can be called by code that is outside the class. So that's number 1 of the 4 parts, where number 1 was divided into 2, well, not just 2, but access modifiers. I believe there's also protected. We haven't talked about inheritance yet, so that's an advanced thing. We'll talk about that later on. So return type. So number 2 is return type, regarding to method headers. So return type specifies whether or not a method returns a value. Number 3 is the method name. So the identifier of the method must be unique in a given program. So this book, sorry, not this book, but the docs. Well, camel case came from Pascal. I didn't know that. Pascal case. Java uses no, I don't believe this is true, because the docs Microsoft, they're referring to that Microsoft docs uses camel case. I don't believe that's true. Perhaps in the user-defined methods that we've been, well, yeah, that I always try to use it if I can. It makes it easier. For like for class names, I'd use capital at the start. Bigger things, I'd use capitals, but for like kind of smaller methods, I just camel case them. What if they came from Pascal? That's interesting. Maybe that's where it was first used or something. Okay, so parentheses. So number 4 is parentheses, number 3 is method name, 2 is return type, 1 is access modifier. So parentheses, a method's name is always followed by a pair of parentheses, so that's where you can put parameters and or no parameters. Yeah, so Canada uses Pearson Education. They pretty much do all the university curriculum stuff. Well, at least they have all the books for it. The authors either work for Pearson or get invited by Pearson or something. Or Pearson wants their book and they make it a Pearson book, which becomes the university curriculum textbook, basically. At least on the West Coast. I haven't been to an East Coast school. I assume that even the East Coast would use Pearson too. Because I know I've seen some Toronto schools that use Pearson Education books as well. And those books are expensive. They're expensive as hell. Like $300, some of them more. But anyways, okay, so let's just have some methods here. I think I had a textbook that was like $337 or $340 just for a book. It's crazy. Okay, so here we can have so let's just say here we have the method header. So the method header, which is not a note. Okay, so the note here is that a method header has 4 parts. Maybe I'll try to do these with periods here. So we have, or maybe I'll go with numbers. Number 1 is access modifier, which are keywords. So keywords that define the access control of the method, I guess. Well, in this case it's a method, but it could just be access control. So these can be basically such as private. This can be private, public. So these can be private, where private is a private method which can be called only by code inside the same class as the method. Whoops, so called only by code. Whoops, it's called only by code inside the same class as the method. Okay, so number 2 here. So yeah, so then we also have public, which is a public method can be called only by code inside the same class. A public method can be called by code that is outside the class, obviously. Sorry. I was kind of looking at my notes and typing at the same time. On a different screen too. So I'm kind of looking around here. Okay, so let's just, that should be fine here. Is there something wrong with that? Yes. Okay, so that's, nope, that shouldn't be like that, sorry. So that's number 1 and number 2. Nope, just number 1. So a method has 4 parts. That's just finishing access modifier. Second type here is return type. So return type specifies whether or not a method returns a value. Number 3 is method name, which is the identifier of the method. So it must be unique, obviously. Number 4 is parentheses. Happened with my keyboard here. So a method's name is always followed by a pair of parentheses. And that's it. So we'll have a little example down here as well. So we might have to split these notes up into 2. We're just about a third way down. Not even a third way down, maybe a quarter down, done at this point. There's still quite a bit to discuss. Try to get about half before I shut it off. So we still have a bit here in this video. So this is just an example of this. So let's just say example. Actually, don't really need to write that because it's not a big example. We can say private void, such as show message. Before that, let's have some parameters maybe here. Actually, well, we didn't talk about those yet, so let's just have that. So here, let's just say we have a message box dot show. Let's just say show message string, whatever. So private void show message. Let's pretend we're showing some message string or something. And so the access modifier is private. The return type is void. The method name is show message. And the parentheses are on the end with no parameters. Those 2 things right there. Alright, so now we're becoming a pro. So now we have, declaring methods inside a class. So methods usually belong to a class. All Visual C# methods typically belong to applications default Form1 class. So methods usually belong to a class. All Visual C# methods typically belong to app's default Form1 class. Okay. So methods are created in the Form1 class. So let's just say we have a Form1. This isn't Form1. Is it Form1? Well, it is Form1. Okay. So methods are created inside the Form1 class. For now, that's the way we've been doing it. We haven't created any other classes, so for now we're just sticking with that. So far we're just sticking, we'll talk about classes later on. So we're just getting to methods right now. So methods will be easier before we move up to classes and objects, so we'll just stick with that. So you don't really need to do another example. This is just the same thing here that we just have, exactly the same thing here. This is the Form1 class right there that we've been using every time. This is the Form1 class constructor, so we'll be talking about those later on. A constructor is a special method. We'll talk about those later on as well. So we'll talk about classes later on and get into why this is a Form1. So we'll talk about that later on. So calling a method. A method executes when it is called. Event handlers are called when specific events take place. So a method executes when it is called. So for example, in this code example here, we're calling a method here. So when we call a method here, then the method executes. Otherwise, a method won't execute unless you call it. It's not like an event handler, where event handlers are called when specific events take place, such as a mouse click or a button click. So yet methods are executed by method call statements. A method call statement is the name of the method followed by a pair of parentheses. So this is a method call statement right here. Get user data. So when that happens, the code execution transfers down to get execution data. It starts here, executes that one, then that one, then that one, then that one. Then when this method is fully executed at the bottom brace, then the line after the method, so the execution would transfer back to the method call, which then that method call would be complete, thus it would go to the next line. That's how the execution works. So the concept of return point. So when calling a method, the system needs to know where the program should return after the method ends. The system saves the memory address of the location called return point to which it should return. The system jumps to the method and executes the statements in its body. When the method ends, the system jumps back to the return point and resumes execution. So when calling a method, the system needs to know where the program should return after the method ends. That's basically what it needs to do itself, like the compiler. So therefore the system saves the memory address of the location called the return point to which it should return. So I assume that when you have a method call here, it'll probably save a return point in memory. So then the system jumps to the method here, executes its statements and its body. When the method ends, which is after this closing brace, it'll go back up here, back up here to get user data, which is the return point. So it goes back to the return point after it's done, so it's just called a return point. So top-down design. To modularize a program, programmers commonly use a technique known as top-down design. It breaks down algorithms to methods. The process is performed in the following manner. The overall task that the program is to perform is broken down into a series of subtasks. Each subtask is examined to determine whether it can be further broken down into more subtasks. This step is repeated until no more subtasks can be identified. So we have the program breaking down the code into subtasks. And the subtasks are examined to see if they can get into smaller subtasks. This step is repeated until no more subtasks can be identified. So once all the subtasks have been identified, they are written in code. So this is called top-down design. So it usually isn't always that complex. Like you can have, doesn't have to be broken down completely, but you would want to break it down into some easier process rather than just doing it like this, like we had before, where just everything's just has to be underneath each other properly with multiple repeating lines. Maybe you could have the same method call repeating itself like 100 times. you have to code everything out over and over again, just making sure everything is linear, that it just executes. Starts at the top and just slowly goes down, using extra memory, extra computer resources, power, time, computer time, all that stuff. So that's what you don't want to do. That's what you want. That's definitely what you don't want to do. So what you want to do is break them down into methods and try to reduce the amount of code and computer time as possible, memory use and all that. So you want to reduce everything so it's more efficient. Sorry, I'm getting tired of reading here. Can we just have this here? Okay, top-down design. So we actually might just leave it there, because it's been over half an hour now, almost 40 minutes. So thanks for watching, guys. So these notes could have a lot of information. So in the next one we'll start with passing arguments to methods. So thanks for watching, guys. If you guys like the video, you can like and subscribe to support the channel for more programming and investing tutorials. So thanks for watching. Hopefully I'll see you guys in the next one. We'll be talking about passing arguments to methods and continuing on with that. So take care. Hopefully I'll see you guys there, and I'll see you guys next time.